Hi children, welcome. Welcome to another chemistry class. Today we are going to discuss the chapter alcohol, phenol, ethers. Some important questions from the chapter alcohol, phenol, ether, organic chemistry from the 12th standard topic. Can we start? Yes, ready? First question. Which of the following is not the product of dehydration of the given alcohol, which you can't get as a product? Very simple to understand. This is the alpha carbon from which OH is going, and this is beta carbon from which hydrogen goes. You get this product. This is beta carbon from which hydrogen goes. You get this product. This is beta carbon from which hydrogen goes. You will get this product. And the one non-possible product is fourth one. That is not possible. And hence, that is our answer. So first one possible, second one possible, third one possible. As this is alpha carbon and this is beta 1. Beta 1, you get this product. Hydrogen from beta 2, you get this product. Hydrogen from beta 3, you get this product. I think it is simple to understand. Dehydration is basically beta elimination reaction. From alpha carbon, OH group will be eliminated. From beta carbon, hydrogen will be eliminated, and that is dehydration process. Okay? Yes. So fourth one is not possible because it is a double bond coming over here. Next question. Most acidic. What is doubt in it? Fourth choice, picric acid. 3 nitro groups, electron withdrawing group increases the acidic strength. 3 nitro group coming, picric acid, having pKa value in the range of less than 1. 0.3 something. It is comparable with the mineral acids. Okay. An acid without a acid group, that is picric acid. And after this, it will be this, then this, then this. This will be minimum. Electron donating group decreases the acidic character. Electron withdrawing group increases the acidic character. Next question. Heating of phenyl methyl ethers with HI produces. Heating of phenyl methyl ethers with HI produces. Always see aromatic ether when you heat with HI, always phenol is one product. Always phenol is one product. Why? Because phenol is one product. You see, methyl phenyl ether means anisole. All of you know this is anisole. When you talk about reaction with HI, the point is whether it is cleaved here or cleaved here. This is not possible as there is a partial double bond character and it is cleaved here. You get a phenol and methyl iodide. Phenol and methyl iodide. Here it will be minus and H plus will be coming there. Here it will be plus and I minus will be coming with that. So methyl iodide and phenol. Always phenol is one product. Okay. Next. Identify major product PQR in the following sequence. You see benzene with a normal propyl chloride. You will get isopropyl benzene, cumene. P will be cumene. The product P is cumene. Cumene process of production of phenol. So this is cumene. You see it is forming a carbocation. Cl minus is withdrawn by AlCl3 and you get a carbocation which will be shifting to the second position giving a secondary carbocation. You get a secondary carbocation which is attacked by benzene. You are getting cumene. So here you have cumene. This is not. Here you have cumene. This is not. So you have cumene P here and here. Now, cumene taken for aerial oxidation, you get cumene hydroperoxide. Upon treating with acid medium, you get phenol and acetone. So, Q and R are phenol and acetone. Phenol, not acetone. And the answer is fourth choice. So, P is cumene and Q is phenol and R is acetone. Cumene process, production of phenol. Learning in the chapter and in the classes. Next one. The most of the worldwide production of phenol is done by cumene process. Next. Compound A on treatment with the sodium gives B. Compound A on treatment with the sodium gives B. And with the PCl5 gives C. B and C react together to give diethyl ether, AbCr. See, if you read the question with the concentration, you can understand the product, the choice very easily. You can easily understand. If you read the question clearly, you can understand. The compound A on treatment with the sodium gives B. This on treatment with the sodium, you don't get this. This on treatment with the sodium, you don't get this. This on treatment with the sodium, you don't get that. This on treatment with the sodium, you get this. And that is the answer. So this is A. Upon treatment with the sodium, you get a B. And with the PCl5, you get a C. This with the PCl5, you get a C. And these two reacting, Williamson synthesis, B and C reacting, you will get a diethyl ether. Williamson synthesis. Very simple to understand. So ethanol with the metallic sodium, you are getting sodium ethoxide. Ethanol with the PCl5, you are getting C2H5Cl. And C2H5ONA with the C2H5Cl, you are getting diethyl ether. Simple manipulation. Option 4. Next question. In the reaction, electrophile involved is, this is very famous, Reamer-Tiemann reaction. In Reamer-Tiemann reaction, the electrophile is dichlorocarbene. Electrophile is dichlorocarbene. Chloroform with the alkali. Chloroform with the alkali. Chloroform with the alkali. OH minus attack hydrogen and Cl minus is withdrawn. And the remaining part of the molecule will be converted to CCl2 dot dot. That is dichlorocarbene, the electrophile which further attack in the system, and you are getting an intermediate which upon hydrolysis you are getting salicyl aldehyde, the very famous Reamer-Tiemann reaction. Right. Next. Compound A C8H10O found to react with NaOI produced by reacting Y with NaOH. So this is obtained by reaction of Y with NaOH. So Y is nothing but iodine. Iodine with NaOH, you get sodium hypoiodide and yield a yellow precipitate. So there is no doubt regarding what is Y. Iodine, 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 iodine. And what is A? A gives yellow precipitate, means you are getting iodoform. So iodoform test is confirmed by compound A. And you know iodoform test is given by molecule containing methyl keto group. The molecules other than carboxylic acid derivatives which contain methyl keto group and which contain methyl carbinol group. These molecules are giving iodoform test. So those molecules which are not a derivative of carboxylic acid and which contain methyl keto group and methyl carbinol group are giving iodoform test. Right? And then what is the answer? Answer is, so regarding iodine, no doubt. This is the answer. There is methyl carbinol group. Here we have methyl carbinol group and that is the answer. Here you don't have methyl carbinol group. Here you don't have methyl carbinol group. This is phenol derivative. So the answer is first choice. Answer is first choice. Now this part of the molecule will be converted to iodoform and the remaining part will be converted to acid group. Okay, next. Compound that is most difficult to protonate. Most difficult to protonate. All are carrying a lone pair of electron. All are carrying two lone pair of electron with the oxygen, which is easy to get, difficult to get protonated. Difficult to get protonated is third choice because these electrons are under resonance with the phenol. The electrons are under resonance with the phenol and they are less available for protonation. While option A, B and fourth choice you can say, compared to that, phenol will be least protonated because that lone pair of electrons are distributed for resonance or less available due to resonance. See, protonation means these electrons attacking H plus. So this tendency is minimum in this case because the electrons, lone pair electrons are involved in resonance. Next question. Structure of the intermediate A in the following reaction is, see this is cumene, already we have commented, this is cumene, cumene treated for air oxidation, what is A? That is a question. Cumene hydroperoxide, cumene hydroperoxide, this is cumene hydroperoxide, first choice. So cumene, aerial oxidation, you get cumene hydroperoxide, treated with the acid solution heating, you are getting phenol and acetone. Cumene process, production of phenol. The name of this is cumene hydroperoxide. There in the text. Next one. Carbinol is methanol. Methanol is called carbinol. Ethanol is called methyl carbinol. Phenol is called carbolic acid. Carbolic acid. Propanol is called ethyl carbinol. So carbinol, methyl carbinol, ethyl carbinol goes on like that. Next. pKa of picric acid. Already I have commented in the previous question. It is 0.3 range. 0.3 range is the pKa of picric acid, which is a low value and is comparable with the mineral acid, and that is one of the strongest acidic character among the phenol derivatives. Okay, next. IUPAC name of the molecule is, IUPAC name of the molecule is, see 1, 2, is it from left or right? 1, 2, 3, 4, 1, 2, 3, 4. So it should be numbered from here, isn't it? 1, 2, 3, 4, 5. So it is 2-methyl pentan, 2,4-diol, 2-methyl pentane, 2,4-diol. Option B is the correct answer. 2-methyl pentane, 2,4-diol. Next. Vinyl carbinol is, first one, this is vinyl group and this is carbinol, vinyl carbinol. What is the other name of vinyl carbinol? Allyl alcohol. Vinyl carbinol, also called allyl alcohol. This is called allyl alcohol. Allyl alcohol. That is the name. Allyl alcohol. Okay. Propan 1-ol can be prepared from propene by propene converted to propan 1-ol. Hydroboration reaction. Hydroboration reaction. What is the importance of hydroboration reaction? propene converted to 1-propanol. The product obtained is similar to anti-Marconic of addition. But of course, the mechanism is different. Okay. So first one, acid catalyzed hydration, you get propan 2-ol. Here you will get propan 2-ol. Acid catalyzed hydration, and according to Marconic rule, oxymercuration, demercuration. Option B, that is oxymercuration, demercuration. Product is similar to Marconic rule. You get propan 2-ol. Right? And the correct answer is B2H6 followed by H2O2 NaBH4. The product obtained is propan 1-ol. And this is what the mechanism happening. All of you know diborane or B2, B3, BH3 interact with the propene. You get a additive product like this. That again interact with the propene. You get two times interact. You get like this. This is alkyl borane. This is dialkyl borane. And again it interact. You get trialkyl borane, which upon hydrolysis with alkaline medium and H2O2, you get propan 1-ol. It is going to break here, here, here. And OH will come on this carbon. OH will come on this carbon. You get propan 1-ol producing boric acid. Right? Hydroboration, oxidation reaction. Next. Rectified spirit. Rectified spirit, all of you know, 95,5 ethanol water is called rectified spirit, almost forming a azeotropic combination. Next. Lucas reagent gives immediate cloudiness with a tertiary alcohol. Immediate turbidity obtained in Lucas reagent is tertiary alcohol. Right? Which is the tertiary alcohol? Butane 1-ol, primary, 2-ol, secondary, 2-methyl propan 1-ol, primary, option D is the correct answer. That is tertiary alcohol. This is tertiary alcohol, 2-methyl propan 2-ol. That is tertiary butyl alcohol. This is a tertiary alcohol which will give immediate turbidity with the Lucas reagent. What is Lucas reagent? Yes, HCl with the anhydrous zinc chloride. It's a test for identification of primary, secondary, tertiary, simple alcohols. Right? Next one. 17. CS3 thrice CCH2OH PCl5. See, PCl5 gives a substitution reaction simply by SN2 mechanism. OH group is replaced by chlorine, that's all. OH group will be replaced by chlorine, and the answer is option A. No other change. No other change. OH group will be replaced by chlorine, that's all. It's promoting a SN2 type mechanism, no other changes, no ionic mechanism. What if it is an ionic mechanism? There can be carbocation formation, rearrangement, and some unexpected product you can get. Fine? Yes. Option A. Yeah, here it will be some unexpected product because it is HCl with the zinc chloride will be, what is the ionic reaction? So what happens? Let's see what is the product obtained here. Here we have, this is what given, neopentyl alcohol, CH3 thrice CCH2OH, neopentyl alcohol. Now, this is getting protonated. This is getting protonated HCl, and you're going to get, I think you are okay with the symbol skeleton I am drawing. It becomes like this, protonated alcohol. Immediately it loses water and you are getting carbocation. You get a primary carbocation. Now comes the twist of the story. All of you know, this methyl group will migrate to this carbon and positive center will be on the second, this carbon. So you get C plus C, C like this. And now Cl minus is introduced here to get the final product. You get it like this. Which one is the answer? CH3 twice CCl CH2 CH3. Option B is the correct answer. Option B is the correct answer as a result of carbocation rearrangement. So that's a very good comparison, previous question and this question. Previous question PCl5, simply substitute OH group. Here HCl with anhydrous zinc chloride, you have to think. First of all, you get a primary carbocation that is converted to tertiary carbocation and then you are getting substitution. Next. Oh, what was the answer given there? Oh, sorry. I have marked the answer here, but the answer key I have marked is wrong. Not this one. Option A. CH3 twice CCl, CH3 twice CCl, CH2 CH3. Option A. Whatever we have written was correct. The choice what I have marked went wrong. Option A itself. Compare this. Compare this. Here you get only that OH goes and chlorine comes. You are not getting option C. See that? PCl5, you are getting option A, not C. And now with HCl, you are not getting option B, rather you are getting option A. I think it is clear. Yes. Next one. Order of acidity. Order of acidity. Most acidic, 4 para-nitro, most acidic. 4 is most acidic. Answer is option D. 4, then 3, then 1, then 2. Correct. 4, 3, 1, 2. This is electron withdrawing group at a para position, most acidic. Electron withdrawing group at a meta position, less acidic. Electron withdrawing group, no groups here. This is next. Here it is methyl group, electron donating group, that is minimum. So 4 maximum, 2 minimum. Option D is the correct answer. Electron withdrawing group increases the acidic character. Electron donating group decreases the acidic character. Okay, next. IUPAC name of the compound is. IUPAC name of the compound is methoxypropene. Methoxypropene. It is 3-methoxypropene. Option C. 3-methoxypropene. Option C. So it has to be 1, 2, 3. 3-methoxypropene. 3-methoxyprop 1 in. Next. 1-propanol, 2-propanol can be distinguished by iodoform test. Yes, 1-propanol, 2-propanol can be distinguished by iodoform test. No doubt. You see 1-propanol, CH3, CH2, CH2, OH, 1-propanol. It does not give iodoform test. It doesn't carry a methyl carbinol group. 2-propanol, CH3, CHOH, CH3, 2-propanol. This will give iodoform test as it carry a methyl carbinol group. There is a methyl carbinol group. This can give iodoform test. 1-propanol does not form iodoform while 2-propanol form yellow iodoform. Yes, both are true statement. Both are true statement. Answer is option. Answer is option. Where is A? B, C, D given. Anyway, the answer is this one. Assertion, reason, true. Assertion, reason, true. Compared to other choices, that is the suitable answer. And it is the correct justification also. There is no suitable choice like that. Reason is the correct explanation of assertion. That is also correct. Okay. Next. This is what the correct choice. Suppose there is a option A, assertion, reason are correct and reason is the correct explanation, we would have selected that choice. Next. Mass of isobutylene obtained from 37 gram tertiary butyl alcohol by heating with the concentrated sulfuric acid if the yield of the reaction is 65% is. That is the question. That's a stoichiometric question from organic, that's all. Mass of isobutylene obtained from 37 gram tertiary butyl alcohol. You see that this is tertiary butyl alcohol and you get isobutylene, 1 mole give 1 mole. 1 mole tertiary butyl alcohol, 74 gram. This is 1 mole tertiary butyl alcohol and 1 mole isobutylene is 56 gram. And how much the mass of isobutylene obtained from 37 gram tertiary butyl. So 74 gives 56, therefore 37 gives half of that, 28. 74 give 56, half of this, 37 will give you half of that, 28. Provided the yield is 100%. But here the yield is only 65%, 65%. So this is the actual yield, the yield expected according to 100%. But the yield is only 65%. So the actual answer will be 65% of this. 65% of 28. It is 18.2 gram. Answer is 18.2 gram. So 1 mole tertiary butyl alcohol, you get 1 mole isobutylene. 74 gram, you get 56 gram. 37 gram, you get 28 gram, provided it is 100% yield. But the yield is only 65%, so the answer is 65% of 28. Option D, 18.2 gram. Next question. The reagent that cannot be used to distinguish between phenol and benzyl alcohol. Phenol and benzyl alcohol. Phenol is phenol character, benzyl alcohol is aliphatic alcohol character. Alcohol character. So this is what phenol and benzyl alcohol. Phenol having characteristic test. This is phenol, OH group directly connected to the benzene ring. And this is benzyl alcohol, CH2OH. The reagent cannot be used to distinguish. This you can use to distinguish. How? Phenol will give the test, this will not. Phenol will react with the bromine water, giving white precipitate. 2,4,6 tribromophenol, not with the other one. Neutral ferric chloride. Yes, this can be used. This will form a complex with the phenol, not with alcohol. Neutral ferric chloride will form a complex with the phenol, not with the alcohol. This is alcohol. NaHCO3. This you cannot. That is the answer. Option C is the answer because NaHCO3 does not react with either phenol or benzyl alcohol. It doesn't react with either phenol or benzyl alcohol. Litmus test, yes, you can. Phenol will give you the litmus test. So option 1, 2, 4 are possible to distinguish while 3 is not. Why? Because 3 does not react with either phenol or benzyl alcohol. Right? Next one. Acetic acid reacts separately with the following alcohols. The rate of esterification highest for. Rate of esterification highest for option 1. Simple acid, simple alcohol give high rate of esterification. As the size of acid group increases, as the size of alcohol increases, the rate of esterification decreases. So simple alcohol, simple acids giving good yield of esterification reaction. Next. In Victor Meyer's test to distinguish primary, secondary, tertiary alcohol, the color produced by 2-methyl propan 2-ol is 2-methyl propan 2-ol is a tertiary alcohol. In Victor Meyer's test, there is a sequence of reaction. There is a sequence of reaction. Primary alcohol treated with red phosphorus iodine giving converted to iodo compound, then treated with the silver nitrate giving nitro compound, and then treated with the nitrous acid and checking the solubility. If you get a blood red coloration, primary alcohol. If you get a blue coloration, secondary alcohol. If you get a colorless condition, that is tertiary alcohol. That is a tertiary alcohol. 2-methyl propan 2-ol is tertiary alcohol, and the answer is option D. It remain colorless. It undergo a sequence of reaction out of syllabus only. If you want, you can check the reaction. You see that this is a primary alcohol with the red phosphorus iodine. You are getting iodo compound. Treated with the silver nitrate, you get a nitro compound. Treated with the nitrous acid, you are getting nitrolic acid, which give blood red color with alkali. Acid contain an acidic hydrogen. Due to the presence of acidic hydrogen, it dissolve in alkali. You see, primary alcohol, CH2OH, CH2I, this H2, CH2NO2, that H2 is able to give a reaction like this. And the product is nitrolic acid, which gives a blood red color. What about a secondary alcohol? Secondary alcohol, same sequence, you are getting a different product. That is called a pseudonitrile. Pseudonitrile remain blue color and is insoluble in alkali. Here you find a hydrogen. That's why acidic hydrogen. That's why it dissolves. Here you not. And what about tertiary alcohol? Tertiary alcohol does not react with the nitrous acid. No reaction with the nitrous acid and no color is obtained. That is Victor Meyer's test. It's a test to distinguish primary, secondary, tertiary alcohol, and tertiary alcohol, no color. Primary alcohol, red color. Secondary alcohol, blue color. Tertiary alcohol, no reaction. Next. To prepare propan 2-ol from methyl magnesium bromide, the other chemical needed is propan 2-ol means you want a secondary alcohol. You want a secondary alcohol with the Grignard reagent. Formaldehyde with the Grignard reagent, you get a primary alcohol. Any other aldehyde with the Grignard reagent, you get a secondary alcohol. Ketone with the Grignard reagent, you get a tertiary alcohol. You have learnt. So it can't be option B. You are not getting second. The answer is option A. Answer is option A. Ethanol with the methyl magnesium bromide, you will get a propan 2-ol. You see this ethanol. CH3, CHO, polarizing as minus and plus, plus CH3, MgBr, polarizing as plus and minus. This is going to come here and this will be attacking here. You get the addition product, that is CH3, CH3, CHOMgBr, which upon hydrolysis you will get CH3, CHO minus becomes OH, CH3. This is what the reaction. This is what the reaction. Now, what about option C? That is an important point to see. Note down. Suppose it is option C. What is going to happen? Let's have a look at. It is going to break either here or here. Anyway, it is breaking here or it can break here. Minus and plus. And you are treating with the CH3MgBr. Splitting as plus and minus. And this minus will get connected here. And this will be interacting with that. What do you get? You get CH3, CH2, CH2, OMgBr. which upon hydrolysis, this will be converted to primary alcohol. You get CH3, CH2, CH2OH. You are getting a primary alcohol. That is propan 1-ol. We want secondary alcohol. So the answer is first one. Next question. In Dow's process, phenol is obtained by starting from Dow's process starting from chlorobenzene. Chlorobenzene heated with fused with NaOH following acidification, high temperature, high pressure, followed by acidification, you get a phenol. Chlorine is converted to OH group, ONA group. You are getting chlorobenzene strongly fused with NaOH. You are getting sodium phenoxide, which upon acidification you get phenol. So it is option C, Dow's process. This is Dow's process. Chlorobenzene converted to sodium phenoxide. Upon acidification you get a phenol. Next one. 15 crown 5 is a crown ether containing a ring made of excluding hydrogen. 15 crown, see, crown ethers are cyclic ethers. Cyclic ethers, that is crown ethers. For example, this is a crown ether which is called a 15 crown 5. What is this 15? 15 means number of carbon atom and oxygen atom. 15 means carbon plus oxygen, 5 means oxygen or ether linkage. Carbon plus oxygen, that is 15. It is written as X crown Y. It is written as X crown Y. X stands for carbon plus oxygen number. Y stands for oxygen number. How many carbon? You see here there is 2 carbon. 2, 4, 6, 8, 10 carbon. And there are 5 oxygen. So 10 plus 5, 15 carbon oxygen. And number of oxygen is 5. And that is the way the compound is named. 15 crown 5. 15 crown 5. X crown Y. Like that. Okay. And the answer is option B. 15 atoms of which 5 are ethers. Next. This one heated with a HI. This one heated with a HI. Once again, I told you, is it going to break here or is it going to break here? It won't break here because there is a partial double bond character due to resonance. So where it breaks, it will be breaking here. And this part of the molecule is converted to phenol and this is converted to benzyl iodide. Benzyl iodide and phenol. Phenol and benzyl iodide. Option D is the correct answer. A question direct from the NCERT. Right? Next one. When this molecule, given molecule reduced with sodium borohydride, another question from the NCERT, the question which appeared latest for the NEET examinations. What is the answer? What is the answer? See, sodium borohydride can reduce keto group, not esters. Here you have a keto group, here you have ester. This will remain as such, this will be reduced. And the answer is option A. This is reduced and this remain as such. Option C is the correct answer. Keto group will be reduced, ester group remain as such. Answer is option C. Answer is option C. Right? Yes. And there we conclude the discussion on the chapter alcohol phenol ethers. We will meet in another session with another chapter. Till then, take care. Bye. See you.